go ahead and look into section 5.5. There's going to be two separate videos. In this first video, we are going to look at the double angle formulas. You might want to write these down, so pause the video and find a little bit of space there on the top of your page, or if you have another notebook that you're writing down formulas. But we've got the double angle formulas. So these formulas are true for, let's see, sine of 2x right here is equal to 2 sine cosine. These are equal to each other. Cosine 2x has, or 2 theta, 2 gamma, whatever you want to use for your angles, but the cosine has 3 different formulas that you can use. Cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus sine squared. So they're all the same. And tangent of 2x just has one formula, 2 tangent x over 1 minus tangent squared. So we're going to use these here for our solving and some of our simplifying. Let's go ahead and look at the first example. We've got example 1, and the directions tell you to use the figure to find the exact value of the trig function. So we've got to find sine 2x, find cosine 2x, and cotangent of 2x. That brings me back to those formulas. I want to show you one thing with these formulas. If you were asked to find cosecant of 2x, well, you would simply just do 1 over the 2 sine x cosine x, and that would be the same for any of the 3. Okay, so you just do 1 over whatever your formula is for the sine, cosine, tangent. All right, I've got a right triangle here. I've got the 7 and the 24 being the legs. If you do the Pythagorean theorem, you do 7 squared plus 24 squared equals my r squared, hypotenuse, and that indicates that we have 25. So 25 is the missing side. It's another Pythagorean triple. So if I'm just doing sine, then sine is opposite over hypotenuse. This is the angle that I'm referring to, so answer is just 7/25. All right, if I were then to look at sine of 2x, because that's what I have a feeling that was supposed to be, sine 2x. Let's go ahead and look to see what that would indicate. Sine 2x is equal to, we've got our formula, which is 2 sine cosine. 2 sine x cosine x. Well, that would be 2 times the sine, and sine is 7/25, and cosine would be 24/25. So what we can do is multiply these here together, and you would want to take your 7 times 24 and multiply that by 2. So 2 times 7 times 24 is 336. So we've got 336 over 625, and 625 is 25 squared. So that's how you would find the sine of 2x. Let's go ahead and look at cosine 2x. And again, it doesn't matter which formula we decide to use. You could use any of the 3. What I'm going to do is I'm just going to go ahead and use the cosine squared minus sine squared. Cosine squared x minus sine squared x. All right, so we've got cosine would be 24 over 25. So that's squared, minus sine is 7 over 25 squared. The results of that are 24 over 25 squared is 576 over 625, and then minus 49 over 625. So my final answer, and I'm just going to keep it in this fraction form, final answer would be 527 over 625. So that is the cosine of 2x. And cotangent, for cotangent, what we're going to do is we're going to do 1 over the formula for tangent, and tangent's formula is 2 tangent of x over 1 minus tangent squared. So we're really looking at doing the reciprocal then, so 1 minus tangent squared over 2 tangent of x. Let's go ahead and substitute what I know. I know it's 1 minus, and tangent would be 7/24, so 7 over 24, and we will square that, over 2 times tangent, and tangent again, so 2 times 7/24. So let's go ahead and work with these fractions. I'm going to go ahead and start simplifying. I've got on top 1 minus, and if you square 7/24, it becomes 49 over 576 over 14/24. I'm going to keep that the same at this point in time. On top, I need to find a common denominator. That would be 576 over 576 minus 49 over 576, and still have 14/24. Simplifying the numerator, I've got 527 over 576, and I can multiply then by the reciprocal, multiply by 24/14. And as I simplify that here, I would get 527 over 336. So that would be your final result there. All right, so that's how you use your formulas, and the final solutions here, you can see that we're just going to leave them in that fraction form. Okay, so we've got, there's the sine 2x, here's our cosine 2x, and cotangent took us a little bit longer right there. All right, that's how you use your formulas. Let's go ahead and look at the next example, which is going to ask us to do some solving of an equation. Example 2 says find the exact solution on the interval of 0 to 2 pi of this equation. Well, here's what I know. Usually when we solve equations, we're trying to write everything in terms of the same trig function, so maybe either write them all in terms of sine or all in cosine, and we're not able to do that here. You could do that if you had some powers of 2. I'm not interested in trying to square both sides at this time, but what I want you to recognize is that we do know that sine of 2 times some angle is equal to 2 sine cosine. These are equal to each other. So is there a way that I can get 2 sine cosine here on the left side? Well, all I'd have to do is divide by 4. So if I divide by 4, I have to do it to both sides. I'm going to get 2 sine x cosine x, which equals 1/2. Well, what that becomes is I can replace this with the double angle of sine 2x equals 1/2. And now I'm solving because I have everything in terms of sine. So on this one here, I tried to substitute a double angle formula. When is sine equal to 1/2? And again, we're doing this for 0 to 2 pi. So I know that sine is equal to 1/2 in quadrants 1 and 2, and that would occur right here at pi over 6, and it would occur also here at 5 pi over 6. But because of the double angle, I have to go around twice. So my solutions would be 2x would equal pi over 6, 2x would equal 5 pi over 6. The second time around, I would have 2x would equal, I have to do a full revolution here. So from pi over 6, I have to come all the way back around, which I'm adding 12/6. So if I had 12/6, then that would be 13 over 6 pi. And finally, the last one, if I go all the way around again, from here, from 5/6 pi, the second time around, I'm going to add 12/6 to that, which would be 17/6. So the reason why I'm going around twice is because of the 2. It's a double angle, so that means 2 revolutions, or 2 times around. Final answer then, I have to divide all of these by 2. So every single one of these equations, right here, I've got to divide them by 2. So x would equal pi over 12, and then 5/12 pi, and then 13/12 pi, and finally 17/12 pi. There we go. That'll be your whole list of solutions here for this equation between the interval of 0 to 2 pi. All right, we will not be doing example 3. It's not in our agenda here to go through example 3. But we will do and look at example 4. All right, example 4 says, given the sine of the angle is 12/13, and we're in quadrant, this would be quadrant 2. Find each of these following. So let's go ahead and look at where we're at. So we're quadrant 2. I've got my angle here so I can make my triangle. This is my angle, and that's x, and so the sine can be found with using the triangle here. Then this is a 12. My hypotenuse would be 13, or the r value, which makes the -5 my x value. So I just use the Pythagorean theorem to do that, to be able to find those missing measures. Sine 2x, so I go back to my formula. This is equal to 2 sine x cosine x. I'm going to replace what I know. So 2 sine x would be using hypotenuse and opposite side, 12/13. And cosine of x would be -5/13. I multiply all of these together, and I'm going to get a value of -120 over 169. So that is the answer to the sine of 2x. Let's try doing cosine 2x. Again, you just want to pick one of the formulas. I'm going to stick with cosine squared of x minus sine squared of x. So let's go ahead and substitute. Cosine would be -5/13. So we're going to square that. Minus sine is 12/13 squared. All right, we're going to square it. So we got -5/13 squared is going to be 25 over 169 minus, and then 144 over 169. So final answer, I subtract and I get -119 over 169. So there we have the results of cosine 2x. And let's do one more. So tangent of 2x. Tangent 2x, the formula would be 2 tangent of x over 1 minus tangent squared. So I'm just getting these formulas from our list of formulas. So 2 tangent x, it'd be 2 times tangent is 12 over a -5 over 1 minus 12 over -5 squared. I'm going to do one thing at a time, so I'm very careful with my operations. On top, I've got 24 over -5. On bottom, I'm going to have 1 minus, and if I square the 12 over -25, I get 144 over 25. Common denominator on bottom. I'm keeping the numerator the same. I'm going to have to do the 144 minus, or I have to subtract the 144 25ths from 25 25ths. And if I subtract 25 minus 144, I would get -119. So with the common denominator and subtracting, -119 over 25. Multiply by the reciprocal. So we're going to have 24 over -5 multiplied by 25 over a -119. Final answer, because I can go ahead and multiply and simplify. The negatives are going to become positive. We get 120 over 119. All right, so there are our solutions here for each of those double angles. All right, your assignment here then is page, for this section 5.5, this first half of the section is page 382, 1 through 8 all, and 17 through 21 odd.